Hello. In this section, we're going to extend on our unit investigation of rational expressions and realizing how in middle school we looked at fractions with numbers, and now we're in high school looking at fractions with polynomials or expressions, and realizing that the way that fractions behave with numbers is very similar to how fractions behave with expressions, and we're going to look at how we add and subtract high school fractions, rational expressions. To start, I like to try a warm-up question reviewing the concept from the prior lesson. Just try another practice with dividing by long division. It tends to be something that takes a little bit of practice, but like things that take practice, the more you practice it, the better you become at it. Soon you'll realize you're kind of a master at it. So try the following. Long division question is just a warm-up. It's a good review. I'll let you know that there should be no remainder. You'll often hear it said that this will go in cleanly. So pause the video now, maybe pause it for a minute and a half, unpause it once you've had a chance to try, reviewing how we did long division with polynomials. So pause video now, please. Come back to see how it's done. Okay, welcome back. Here we go, let's give it a try. I'm going to assume that you've already seen long division with polynomials before, so I'm not going to reteach the whole concept. If you need to, go back and watch the prior lesson. X is my guide. It's the biggest power in this binomial expression, so I'm asking myself, what do I need to multiply x by to get to x cubed, or how many times is x going to x cubed? Well, I need an x squared. X squared times x will make x cubed. X squared times 3 will make 3x squared, and then I subtract. These cancel out, which lets me know that I chose this appropriately. 7 minus 3 makes 4 x squared, and then I bring down the 10x. Then I just repeat. Ask myself, what do I need to multiply x by to get to 4x squared? How many times does x go into 4x squared? However you want to phrase it. It needs a 4 and it needs an x. Then I multiply. 4 times x will make 4x squared. Chose appropriately, those will cancel out. 4 times 3 is 12. X, subtract. I'm left with what? A minus 2x. Bring down the minus 6. What do I need to multiply x by to get to negative 2x? Well, clearly I need a minus 2. I don't need any extra x's. I'll get left with a negative 2x and a minus 6, and once I subtract, all these will cancel out to make 0. Minus a negative is a plus. I get 0. It goes in perfectly, and there is my answer. I could check by taking x squared plus 4x minus 2, and if I multiplied it by x plus 3, if I do double distribution 3 times, I'm going to get it to equal x cubed plus 7x squared plus 10x minus 6. So that was a review of a concept from last section. So last section we looked at specifically dividing. In this section we're going to look at adding and subtracting. So this little lead-in is actually very similar to how we're going to think about items today. If I asked you how much money is listed right here, you'd probably take a second and you'd count it. You'd say, oh, there's 82 cents, right? And somebody first learning this, like a child, might say, how that's making sense? You have 3 dimes plus 2 quarters plus 2 pennies. How can you possibly add those things together? They're all different. You have dimes, quarters, and pennies. And you'd say, oh, well, no, this is 30 cents, this is 50 cents, and that's 2 cents, because what you're doing is you're getting like terms. In math, we call it a common denominator. Instead of saying 3 dimes, you actually are thinking 30 cents. Plus 2 quarters, oh, that's 50 cents. 2 pennies is 2 cents. I add that all up and I get 82 cents. So you do it with money all the time. You get a common denominator. You get like terms. Here, if I had, what is this? This is 3/8 plus 2/5. So this is kind of the elementary version of what we're going to do today with money. This is kind of the middle school version of what we're going to do today with fractions. 3/8 plus 2/5. How do I add those two things together? How can I add two things that aren't counting the same size pieces? I've got 8 and 5ths. I make them be counting the same size pieces by getting them a common denominator. Let's make them both be 40ths. So multiply this top and bottom by 5, this top and bottom by 8. 3 times 5 will give me 15. 8 times 5 is 40. 16 over 40, add them together, it is 31/40. So that is how you did it in middle school. We're going to see what it looks like today, but the takeaway is if you're going to be adding or subtracting, you need a common denominator. Once you have a common denominator, let's point that out. Notice, once you have a common denominator here, how do you add fractions? You just add the tops. In a fraction, the bottom is the name of the piece, the sizes of the piece. The top is how many you have. So when you're adding or subtracting, the top parts are really the only parts that are going to combine together to add or subtract. Just like over here, cents, and cents is just the title of the pieces. These are 40ths and 40ths, just the title of the pieces. It'd be exactly the same as if I wrote this as 15 40ths, however you spell it. I think it's that, plus 16 40ths. That's just the title of it. Okay, that's important to keep in mind. So let's try it. It's the high school version of what we were talking about prior. Hey, notice I have a common denominator. How do I add if I have a common denominator? I just add the top parts. 3y plus y squared. 3y plus 1y squared. Those aren't any like terms, so I can't simplify it. So I just write 3y plus y squared. Down below is 3 plus y, but now I look to see if I can simplify, because sometimes when you add fractions, you might get something like your answer is 4/6, and you might realize I can reduce it. So can I reduce this? Yeah, because I can factor the top. What do they have in common? They both have a y that I could divide out, so let's try. I get then, what's left then? A 3 plus a y left behind, and I'll notice, hey, the bottom is 3 plus y. Those are going to cancel out, make the number 1, and I'm left with that's just actually y once I add it all up. So there you go. Add, if they have a common denominator, you just add the top parts and look to see if you can reduce it, simplify it. Second one. Hey, look, I have a common denominator again, but this time I'm subtracting. So I'm going to be very careful when I write this, though. This is 2h plus 4 over, well, yeah, over h plus 1 minus 5 plus h over h plus 1. Realize, though, when this is subtracting, it's going to subtract each piece. If you want to think about it, this subtract will distribute this. This will make a negative 5 and a minus h if you want to think about it like that. So now I subtract each piece. 2h minus h is 1h. 4 minus 5 is negative 1 over h plus 1. And some people are going to be tempted to try to say, oh, these h's will cancel out. This negative 1 will make negative 1. No, these are, h plus 1 is grouped together. That is one expression. H minus 1 is grouped together. The only way I could cancel anything out would be like if there was another h plus 1 up here, but there is not. So these two items are not the same expressions. They cannot simplify. That is your final answer. I'll try one more before I have you try. These are really close. Look, it's p minus 4 and 4 minus p. The only difference is this is a positive p, that's a negative p. This is a negative 4, that's a positive. So I need to rewrite this bottom so that it will be a common denominator. So what the problem is, the bottom, they're opposite signs. So what am I going to do here? I need to multiply this bottom by a negative 1 in order for it to match the bottom of this one. Well, if I multiply this bottom by a negative 1, I need to multiply the top of this fraction by a negative 1 so it stays the same fraction. I'll then have 3p over p minus 4 plus, when I multiply this whole top by a negative, this will become a negative 2p, and then a negative, it's distributing, that's what it's doing. Negative 5 times a negative 1 makes plus 5. All over now down here, if I distribute through, I'll have a positive p, I'll write that first, and then a negative 4. And voila, they have a common denominator. I can now add. 3p plus negative 2p is p. This is technically 0 plus 5 will be 5. Down below is p minus 4. Put parentheses around your grouped expressions so you don't go canceling things that can't be canceled. These p's can't cancel. You can't cancel parts of an expression. That would literally be like if you had the number 15 over 14 and you said, oh, and I can just cancel those ones, and 15 over 14 is just 5/4. No, that's not true. The 1 and the 5 are grouped together, just like the 1 and the 4. So these are p plus 5 and p minus 4. P plus 5 is one expression, p minus 4 is one expression. You can't go canceling those things out. So that is as simplified as that statement can get. I'm going to have you try. You try the following. First one, you'll notice they have a common denominator. Should be a fairly straightforward question. Go back and look at how we did the first one. Second one, you're going to need to manipulate it a little bit. So pause the video now for maybe a minute and a half, 2 minutes, should be plenty of time. And then unpause it once you've had a chance to try. And come back and see how it's done. So here we go. The first one, your answer should just be the number 5. How do you do it? Common denominator up top, just add the tops. You get 5m plus 15 over m plus 3. The top can be simplified to greatest common factor factoring, and you'll realize you have a common factor of m plus 3 on top and bottom. Voila, you're left with 5. Second one is just like the one we did prior, 3m minus 5 over m plus 4. You need an opposite sign, so you have to multiply the top and bottom by a negative. When you multiply the top and bottom by a negative, you have a negative 4m minus 2 down below. It'll then be m minus 4. Then you just go subtracting. 3m minus negative 4m is 7m's. Negative 5 minus negative 2 makes negative 3. This is one expression. That is one expression. You can't simplify it any further, and you'd be done. So there you go. Another way you could see this written, so just letting you know, when you multiply the top and bottom by a negative, you might see some people multiply the bottom by a negative and then change this to be an addition question with the original. So it could be written as 3m minus 5 over m plus 4. And then when you multiply the bottom of this by negative 1, obviously that'll make it be m minus 4. And instead of multiplying the top by a negative 1, you could just change this to be an addition question with the original top, and you'd have the same problem. 3m plus 4m is 7. Negative 5 plus 2 makes negative 3. It's the same idea. So however you want to think about it. There's the first part. So that's adding and subtracting when you have a common denominator. Now, we need to do it when you don't have a common denominator. This is kind of equivalent to if you had the following question in like elementary school. If you had 3 over 15 plus like 2/5 or something like that. Okay? Well, how would you, well look, 5 and 15 aren't common denominator. I need to adjust this one to make it match the left one. That's exactly what's going on here, but you won't realize that until you do the very first step, which is you should factor everything that you can so you can really see what everything looks like. So factor everything that you can. Can I factor 3x plus 2? Nope, there's no common factors. X plus 1 is already factored, x minus 3 is already factored. The bottom left is where I need to factor. So 3x plus 2, if I factor the bottom left, I'm going to realize it's an x minus 3 and an x plus 1 plus x plus 1, x minus 3. I need to add these fractions, but they don't have a common denominator, just like these don't right here. Well, how do I get from 5 to 15? I multiply the top and bottom by 3. Same thing here. How do I get this bottom to be this left bottom? Well, it's missing an x plus 1, so I need to multiply the top and the bottom of this by x plus 1. Then I will notice, hey, they have a common denominator. I can simply add the numerators. So I get 3x plus 2 plus x plus 1 times x plus 1, all divided by the common denominator of x minus 3 over x plus 1. It's the same thing you did with fractions over here. Once I have 13 over 15 plus this is 6, so I end up getting 13 plus 6 over 15ths. Eventually I'll write it as 19 15ths. Here I need to simplify before I can add my like terms together. So I need to distribute this x plus 1 times x plus 1. So 3x plus 2 is just waiting for it to simplify out. X times x is x squared. X and 1 will make 1x, another 1x, so I get 2 x's. 1 times 1 is 1, all over x minus 3 times x plus 1. Add up all your like terms here. I get x squared plus 3x and 2x is 5x's. 2 plus 1 is 3, all over x minus 3 times x plus 1. Now, just like in middle school, when you get a fraction, you should always check to see, are there any common factors between the top and bottom? Like 19 and 15 don't have any common factors, so that one's answered. I would look to see, can I factor the top? Because if I could factor the top and maybe it became like an x plus 1 in there, then an x plus 1 on top would be able to cancel with an x plus 1 down below. But as it stands, there are no two numbers that multiply to be 3 and add up to be 5, so the top can't be factored, which means it won't be able to cancel either of these expressions down below, and that means we've got our final answer. So there you go. If you don't have a common denominator, you're going to have to get one. So you need the bottoms to match in order to be able to add. So step 1 was factor. Step 2 was get common denominator. And then step 3 is add and simplify. I'm going to try one more before I have you try one. So 6x over 4x plus 8 plus 5x. This is really 5x over 1. 6x over 4x plus 8 plus 5x over 1. How do I make this be a common denominator? Well, it needs the whole left side. It needs 4x plus 8. So I need to multiply the bottom by 4x plus 8, multiply the top by 4x plus 8. Now the bottom of 4x plus 8 is a common denominator. I add the top parts. This is a 6x plus, this would distribute through, I'd get 20x squared plus 5x times 8x is 40x's. Simplify. 20x squared, biggest power first, plus 46x, all divide by 4x plus 8. Now factor. What's the biggest thing I can factor out of 20 and 46? Well, things that go into 20 are 4 and 5. That won't go into 46, but 2 will, so probably a 2. And an x I can divide out. What's left behind? An x plus 23. Down below, 4 will divide out. I have an x plus 8, so it'd be what's left behind is an x plus a 2. I look and see these won't simplify, but 2 over 4 can simplify. 2 over 4 becomes 1/2, so this will be a 1x, x plus 23. This 4 became a 2, x plus 2. And you'd be done. You actually would see in the book, they don't write this 1 there. They would just leave it as x, implying the 1. There'd be your final answer. Nothing else to simplify, so you're reduced. That's it. Gonna give you a chance to try. You try the following. This one's a subtraction one, but you need to get a common denominator first. You're gonna have to multiply this right fraction by something to get a common denominator. So pause the video now, unpause it once you've had a chance to try. Okay, welcome back. Here we go. First thing you need is a common denominator. You'll realize this left side factors to be x plus 3 and x plus 5, so that means the right side is missing x plus 3 on top and bottom. Now I have a common denominator. I can subtract the two statements on top and bottom. I multiply x plus 3 times x plus 3 here, so I simplify this out to be x squared plus 6x plus 9. Realize it's subtracting, so it will distribute that negative into all of the items up top. I'll be left with then a 2x minus x squared minus 6x minus 9. When you simplify everything up top, you get a negative x squared minus 4x minus 9. You could divide a negative 1 out if you'd like to, but no number will multiply, or no numbers will multiply to be 9 and add up to be 4, so it won't factor anyway. So you'd be done, and there's your final answer. And that's it. That's how you add and subtract with rational expressions. They're just kind of like fancier fractions. You need a common denominator. Thank you very much. Have a good day.